everyone. Today we are going to be looking at if statement. How do we implement the if statement in Python? That's what we are going to be looking at. If you look at my screen, you will see I'm going to look at if statement, then we'll look at if else statement, then we will nest if else statement, and then we'll do a little practice session, and then if we have time, we will introduce functions. So what is if statement? If statement is you have a condition. If this condition is met, do this. If it is not met, then don't do it. That is what the if statement is about. So let's put this into practice. Now, when you give a condition, or when you give conditions, the outcome is a Boolean value, true or false. If it is true, then whatever you have in the if statement will work, then will be executed. If it is not true, it will not be executed. Let's look at something there now. When we go over here, we use an if statement. We say score is equal to 69. Now, we are given the if statement. If score is greater than or equal to 65, then your remark is pass. So, now, if we look at that, then we now say we print remark. So whatever the remark is will be printed here. However, in this situation, it is only when the score is greater than or equal to 45. That's what we have instructed it. So let's run this code. You click on the run button and you see it says pass because this condition was met. You remember what we did in truth table. Any of them greater than or equal to 45. So as long as we have a number that is greater than or equal to 45, the remark will be pass. That is the if statement. The remark will be printed out. Let's change this value and see what is there. If we do 45 and we execute, we still have pass because it is greater than or equal to. So this condition is true. Score is greater than or equal to. But if we get score less than 45 and we run that, we'll see that we do not get, it's just printing remark because remark is assigned here. Let's get this, get this, restart the kernel, restart the kernel, then we run this. We see that there is no remark. Remark is not defined. Remark is not defined because we have asked it to get remark. And so it passes an error because this condition is not met. So it does not see this remark is equal to pass. If we want to check how that works, we do that. And we put a blank there and run that. You see that now, because remark has been defined, it says a blank. It gives a blank because the statement does not, the execution does not get into this. But the moment we get a score greater than 45 or equal to 45, let's have 60 there. You see that the remark now becomes pass. Now, this is a condition where we are considering only one condition. So if it is not pass, if it is not greater than or equal over, what do we do? That is where the else statement comes in. So let's include the else. Remember, this else must be on the same line with the if. The else must be on the same line with the if. If we go in, if we tab it in, then we are going to get a wrong, that's going to be a syntax error. So we now say remark is equal to. Now, we said if the score is greater than or equal to 45, the remark is pass. Else, the remark is fail. That's what we have said. So now we have two conditions. If not this, if the first condition is not met, then take the second condition. Meaning that you have just, if the first condition, which is score, is greater than or equal to 45, then the person passed. Else, the person failed. So let's run that and see what happens. You see, the remark is pass. But if we change this to 40 and we run that code there, you see that the remark is now failed. When we started the code, score is assigned 40, but remark is assigned blank. Now, we said if the score is greater than or equal to 45, the remark should be made pass. Else, the remark should be made fail. Now, we come out here to print the remark. Now, we are printing this remark. The print is on the same line with the if and else. That means whatever remark is, this line of code will print it out. But if you put this print inwardly here, then the first part of the code will not see it. Then it will only print when remark is failed. Let's try that and see what happens. Now, in this case, this print statement is not being seen by the if top layer, segment of the code. So if you run it now, you see the fail. But if we change this, so let's say 70, it does not print anything because it is not seeing this code, this part of the print statement. The compiler gets into, or interpreter gets into this block, the if top segment of the if block, and so it does not see this print. But if we bring this print out and run this code again, you see it gives you pass, because whatever is assigned, whatever remark is, will be printed here. So this is an if else, trying to show you the if else statement and then the print statement where you position the print for it to pick any remark that comes in. Now, it does not necessarily mean that you are going to only do remark. Whatever bunch of code, whatever you want to do after the first condition is met will be inserted between the if and the else. Then whatever condition or whatever execution you want to perform will be inserted after the else. Now, this is a situation of two conditions, if, else. Just two conditions. If it is not this, then should be this. How about a situation where we have multiple conditions? Multiple conditions. For example, we have a student could score an A, the grade will be A, B, C, D, E, or F, as the case may be. What about that? What do we do in that case? Is it just if else? Yes, we could use if else, in which case we nest if else in another if else. We continue nesting until all our conditions are met. We nest one if else structure inside another if else structure. So let's give it a try now. Let's agree that we have score is equal to 17. Then we have a remark grade is equal to, I could make a blank, or I could assign the grades inside the loops, inside the structure. But I'll do, this is called initialization. You are initializing the grade now. I say if score is greater than or equal to 70, sorry, equal to 70, and score is less than 101. Grade is A. We have said score is greater than or equal to 70 and score is less than 101. You can see how where our truth tables are coming in now. You see the and, you see the or greater than or equal to, whichever condition one is true, and then when the condition on this other side is true, the and operator now merge the two should be true for this to be true, for that statement to be true. We have now said grade is equal to A. Now, else. Now, instead of this, to nest an if-else statement, now we have said else if. This is a situation where we are nesting a if-else inside another if-else. So now we want to state the condition. You will see that the else if has changed to green, meaning it is a reserved word. So else if we want to state the condition, score greater than or equal to, equal to 60, and score is less than 70. You see the boundary conditions. The boundary is 70. That's what I have here. That's why I have less than. I'm not going to include equal to. I cannot include equal to here. So what do I do? I'll say grade is equal to B. Now, this if, the first if here, and this is its own else. Now, this is a different if, which is nested into the first if else. Now, I'm going to have an else for this if. So I'm going to have else. Because the conditions are many, I still want to have another. Okay, let me just give the else first. Else, great, is equal to because I have other conditions, I have written that something not A or B, meaning that is not A, the grade is not A, neither is the grade B, but something else. So let's run this and see what happens. And then let's print out the grade. Grade. Print. Grade. Now when I run this, you see it gives me an A because score is 70. If I change this to, let's assume I get 50. Now if you look at 50, you'll see that 50 does not fall into A category, neither does it fall into B category. So let's see what is going to happen. Something else. The grade is something not A, not B. So we see that we have one if else and we nested another if else into it. Now this, we have looked at a situation where we have just 3 conditions. We can continue this for many conditions. So for us to continue this, let's nest another if else into this block again and see what is going to happen. I'll delete this. I want to give a situation where I'm going to give a C and a D. Greater than or equal to 50 and score is less than the boundary condition. This is a situation where, sorry about that, where the score is greater than or equal to 50. However, it is less than 60. So in this case now, I'll say grade is equal to C. Now, I want to go on to add another one. I want to add that of D. Okay. I'm adding another if else. For D, in NDU here, we have 45 to 49 is D. So I will say it's greater than or equal to 45 and score is less than 50, the lower bound of the other one, less than 50. Our grade should be D. Our grade should be D. Grade is equal to D. Now we have brought another if else, so let us take the last one where we have F. Now we say else grade is equal to F. Now let us run this code and see what happens. Before we run the code, I'll take you through it. Score is 50, grade is blank. Oh, look at this grade. Here we have capital G and here we have small letter g. So that's going to give us some error. So we change this to small letter g so that it agrees with these other ones. Now, if we run this code now, we see the grade is now C because it falls in the C category. If we change this, I'll change it to 60. 60, our grade is now B. Our grade is B because it falls into this, the B group category. Let's change it to 65. We run that, we have B. Now, as a programmer, you must consider certain factors. How about somebody made a mistake of um, imputing some wrong value, like 115? 115, what will it give us? It will not be A, neither will it be B, C, D, E. It is going to give us F because it does not satisfy all the other conditions. So let's print that, F. So when somebody gets a score of 115 out of 100, it is quite certain that either there is an error somewhere or there is misspelling or typographical error somewhere. So we have to consider all that. Now, after D, we still do have score between 0 and 44, which is the F. So let's consider that, include that in our code now. I say else if score is greater than or equal to 0 and score is less than 45, which is from 0 to 44. We say great, it's F. Now, we have now assigned a value F from 0 to 44 is now F. How about what takes care of the situation where there is a typographical error or something? So what we will now do is we are going to put the else for this if, and that is going to be else the grade is equal to, put a string there, invalid score. Please check. Score entered. Score entered. Now that's the message we want to get for invalid score. And so let's run the code now and see. You see, now it says invalid score. Please check score entered. So this is how we use the if-else statement. We have showed the if statement, we showed the if-else statement, and we have also nested if-else in some other if-else. So we can see that now. This is how we use the if-else statement, and we nest. This is how we also nest the if-else statement. One thing you have to look at is, one, we see the alignment of the if-else. See the alignment. If you make the mistake of not aligning them properly, Python will not accept it, and you will have a problem. Now let's go back to this print statement and take this, assuming we put the print statement there, and if we run this now, it is going to print the invalid score because the print statement is in this block. However, if we go back to change this score to, let's say, 80, and we run this code, you'll see that the grade is not printed because this block is not the first block, A block, is not seeing this print statement there. But if I put it back in its rightful place, which is there, and I run this code, you see that the A is printed. That is how we handle Python program and if else in this case. Now we have been able to demonstrate the if else statement, nested if else, and then we have been able to demonstrate if. Now, the challenge now is, would we at every point go to change this score? No, we can't do that. We can't do that. That is not good. We are going to introduce what we call a function. A function in programming is you give it something, it does something for you. It gives you an output. If you want the output, you say you return the function, it does the return. There are several types of functions. Functions that accept parameters. Parameters means variables, a value that you give to it and it uses that value. There are functions that don't accept parameters. You just give it a function, you just call it, and it gives you something to do. For example, range, random numbers. If you say random, if you just say random, it is going to give you a value between 0 and 1. But if you pass in a value, it's going to give you within that range of values you give to it. So now we want to convert this to a function. So we are going to see how we convert this to a function, and then we are going to see how we can call the function. So we have tried this code. We have seen that this code is working perfectly well. We can change the values here to get to test to see. You see 40, we get F. We have changed the values there and we see how the code is working perfectly well. Now, how do we put it into a function? Having gotten this, we package this into a function. How do we define a function in Python programming? The word def means definition of a function, and then you give the function name. Let us call it grade calculator. Grade calculator. I call that function grade calculator, and then I'm going to pass in. What am I going to pass in? What am I going to give it? I call it score. Score in this case, and then I do that. Now, when I do this, I can return. What am I going to return? I'm going to return grade. That is the structure of a function. The function is created. Now, between these two lines, you are going to put in the code of everything you want to do. So we are going to take this. I'm going to take this from this point. I'm trying to copy the thing and it's not going. I'm trying to copy this and it's not going. Okay, I copy that cell. And I come here and paste it. Now, having pasted that, this is the beauty of Python. Now, I'm going to remove this because I'm going to pass in a value. Now, this alignment is going to give us a lot of errors. So, the alignment, if you enter that is where the whole thing is supposed to be aligned to. So, I will do that. That is aligned now. This is aligned. That is aligned now. That is aligned. What I do in this case, in each of these cases, is for these blocks here, I tab. When I tab, I put my cursor there and I enter. It brings it at the correct point. And that's what I'm doing. I'm doing all through. So all these ones will have to be on the same line with this. As it is now, this is not part of this function. So if you run it, you have your serious error. This is not part. So when you shift it to this line, then it becomes part of this function. So that is what we are going to do till we get to the end. Now, we get this, we tab, and then we put our cursor there. Put our cursor there, we enter, and we delete, and we get it at the right place point. We get here, we tab, and then we put our cursor there, we enter, we delete, and get it right. Get here, we tab, put our cursor there, we delete, enter, we delete, and we get it there. Then we put our cursor here, we tab, and then put here, we enter, we delete, and that is that. This print, if you look at it, it's on the same line with the definition of the function, the def. So it's not part of it. So we will have to tab this, and then that is it. So now I think we are good to go. Now if we run this and we don't find any error, it means our code is running. Our function is fine. We try it again, run it again, we don't have any error, which means our code is fine. Now we have defined a function. How do we call the function? We get this grade, let's say, if we say grade car, now we have to pass in a value because it shows that the function shows that we need to pass in something. So we have to pass in something here. And then let's assume we pass in 68. And then we run that, pass in 68. And we said return grade. We said return grade. So return grade means it's going to assign it to something. So let's call it, let's say SOF. Assuming we just create a variable there. And then we now say print SOF. Now if I run this now, I see I get a B. Now why did this show two B's? You see it showed B and then it showed B again. This function runs and this print grade here is the first B. This one, this second one is the second B. Let me show. This first B is as a result of this print. This second B is as a result of this print that we call the function, give it a value, call it, and we store the output of grade into a variable which we call SOF in this case, and we say print that variable. So that is why we have it twice. So if we remove this, then we are going to see what happens. Let's remove that. Let's delete this one so that we don't have the grade printed twice. I have the grade printed twice. If we run it, then we come here, we run again, we see we have the grade printed once. In this case, the function is returning the grade and storing it in a variable, and then we print the variable. So in this, like this, we can now get as many, we can call the function as many times as possible. All we need to do is to change the score. So let's change the score and see what is happening there. We'll get different scores and then see what happens. Let's say 38. If we say 38, that's F. You see, the function is telling us 38 is F. Let's make 118. 118. Let's see what happens. It's an invalid score. Please check score entered. That is it. So we can change the grade and let's say 54. 54, we run it, we are expecting to get a C, and that is a C. So we have seen how we can use the if statement, the if else statement, and then we nested the if else statement in another if else statement. We nested the if else statement in another if else statement. We run the code and we now created function. When we created a function, we see how a function is created, and we also see how we can call a function. So by calling a function, we said the name of the function, what you call it, the name you give to the function, and the parameter. Whatever you have here is called the parameter. The parameter you pass, are they 1, 2, or whatever. In our case now, it's just one parameter we call score, and we use that to do our calculation and find our grade. We get a function and we saw how we call the function. You can assign the output of the function to a variable. If you want to assign the output of the function to a variable, then you say return, and that what you are returning back is what you return here. But if you don't want to assign the function to a variable, you can just print here. I can just say print grade. If I print grade and run this, the code is running now, the function is working. I run it again, function is running. Now let's see what is going to happen in this case here. Now, here, the print grade, this print grade is giving us, this C. But we did not say the function should return a value to this variable. So the function in this case is not returning a value to the variable. That is why the print statement does not see anything. That's why it says none. So the print here, the C you see here, is the grade that is printed here in that function. Now, if we want it to return a value, we are going to convert this one to a return statement, and we see what happens, just like we did previously. So if we change this to return, and then we run that and run that, we see that now it is giving us the C from this print, not from the function. If we want it from the function, then we will have to, if we include the print grade, you see that this time we are going to have the C coming out twice. Now we are seeing the C coming out twice again because the first one is the print from inside the function. The second one is the print from the variable. But we are going to do away with this. Just doing this to show you, to demonstrate how we do that. So we clean that off, and then run this, and run this, and we get a single digit. So we can adjust this number to whatever we like, 65. This we are testing. B. Now, it is good for us to test with the boundary conditions. So we are going to test with 70, 60, 50, 45, and 0. So we do 70, 60, test with 70, 70, we run that, A, we get 60, we test 60, 60, we run that, B, we get test 50, we run that, C, we test 45, run that, D, we test 0, run that, F. So that is how it goes. Let's try a number that is more than 100 and 100. 102. So we have invalid score. We have invalid score because actually this score is not valid. But if we make it 10, assuming that 10, you see we get F. So what we have done this much is that we have been able to demonstrate the use of if statements. We have been able to demonstrate how we can nest if else inside another if else. That's what we have done. And then we have been able to define a function. What is a function? And we have also been able to call a function. How do we call a function? That is what we have done. So all you need to do is with this code now, we can find the grade of students. We can find what their grade is, whatever. Now, having done that, we have also demonstrated the use of the truth table or operator here, greater than or equal to. We have demonstrated the AND operator here as well. So we have seen how we use the truth table. We have also seen the if-else statement. We have seen the if statement, the if-else statement, the nested if-else statement, and we have also defined a function, how we define a function. In addition to showing how we call a function. So that is what we have done so far. We are going to continue with this in the lab. Your new students will have to do this in the lab themselves. Meanwhile, let's look at something a little and see what happens. Let's assume that we have a list. We have data. Let's call this student data. Student data is equal to, call this, we call this 45, 78, 90, 67, 55, 46, let's call it 56, 34. Now, let's assume this is students' data. A lot of them. They could be 1,000, they could be 1 million, it doesn't matter. Now, we want to find each of these scores. What is their grade? what is their grade. We now want to introduce another concept, the lobes. The lobe. Now, we use a for statement. Now, if I say for item in student data, now what that means is that for each item, each thing in this data, I want to do something. Now, I will read the data. When I read the data, I will now pass it to the function that we use to calculate grade. That's what I will do, so that it will be able to tell me which of them had A, who is having B, who is having C, who is having D, who is having F. So that's what I want to do now. So I'll enter this. I'll say item equals integer. Now, what do I mean by that? What I mean by this is that when I read an item here, take it, ensure it is an integer value, ensure it is an integer, you change it to integer and store it back in the variable item. Now, I will now want to print out the grade. I'll say now this is what I do. I say grad. I call it grad in this case for you to see the difference is equal to. Now I want to call my function grade cal. So I'll call it grade cal. I'm supposed to call that function with one variable. So the variable is now the item. Now, I will now ask it to print. I'll do now say print the item. No, let us just say the grad for now, grad for now, and then now what is happening is that the function calculates grade cal is picking each item, storing it in this variable, and then printing the variable. For each item, it will print, it will come here. What is happening is it has gotten this data. So we say for item in this student's data, for each one, you pick that item, you ensure it is an integer. That's what we have done here. Ensure it is an integer, store it back there, then pass it into the function grad cal, the function we have demonstrated, we have used there. When you pass it, whatever grade it returns, store it there and print it out. When you do that, you go and take the next item again. That is what the for loop is. We are repeating, going through till we get to the end of that data. In is a reserved word as well. So for every item, just like in the English language, in this data set, do that. So let us run the code and see what happens. We run this code, and that is the result. That is the result we got. So now let's look at the results we got. The first item is a D. We agree it is a D. The second item is A because it's greater than 70. The next item is, the first item is a D, yes. The second one is an A. The third one is A. This is F, so that's why you have F there. This is a B, that's why you have B there. This is a C, that's why you have C there. This is a D, and so we have D there. So we are left with the last two, which is 56 and 634. And so 56 is a C and 34 is F. So we see that we can get the function and use it to call the function as many times as we want. That is what we have demonstrated. So we have demonstrated again we have demonstrated the for loop. That's my cursor. We have demonstrated the for loop. Say for item in student data. We have defined a student data, which is a list, and then we say for item in student data, this is what we want to do. For each item, take that item. For each item, come here, take the first item, which is now item. You can name this anything you like. Depends on what you like. If you change it to anything, just ensure it changes everywhere. Let's try that. Some people would think it must be item. So let's change this to, that's my cursor. We can just call it anything. Let's call it boy. What we now have to do is if we change this to boy, that's all. We change this to boy, it will still run, same thing, you see that? Same thing. We can change this, we can put this thing same here. The most important thing is that what is here should be here, and what is here should be here. That's all. We can just change that, and that's all. And then we get our grade calculated. Some persons might want to say they want to see the value and the grade. We want to see the value and the grade. Let's do that and see what happens. We see we want to print the value and the grade. We are not going to mix them up yet because we have not done things like that. So we are going to just say item. So in this case, what is going to happen is that it reads this here, converts it to integer and store it as item. That is what I want to print out. So I give you the value here, and then I also give you the grade after the grade has been calculated. So I'll run that code and let's see what happens. Boom. And that is it. So if we go down here, you see that we first of all printed the first grade, 45. You see 45 is a D, 78 is a A, 90 is a 43 is a F, 67 is a B, 55 is a C, 46 is a D, 56 is a C, 34 is a F. So we've seen what we have demonstrated. We have demonstrated how we can use the for loop as well. The for loop can be combined with other functions. However, we are not going to do that today because we have done a lot today. Now, this type of data is called a list data structure. That's going to be a lecture of its own. That's going to be a lecture of its own. Now, in the next video, we will be looking at using the for loop and some other functions like range, and then trying to see how we combine them using the for loop and the range, the in, and all those things. We combine some of those things to see how we can use them with functions we created. We can create functions and do whatever we like, whatever comes to mind, we can do that. So at this point, we will review and end the lesson. So what did we do today? What did we do today? We go to the beginning. Yes, we first of all introduce the if statement, and then in the if statement we have a condition. Here we have um, or table greater than or equal to. Then we introduce the if statement, and we say in the if statement we have just one condition. Then we have the if else statement. If this condition is not met, what else? The next thing. So if the first condition is not met, then the else statement. We tried to demonstrate that with a pass and a fail condition where the student can, there are only two options. The student either passes or the student fails. So in a situation like that, we just have two conditions. You either pass or you fail. So here we did that, so we just have if else. Now we enter a score, and the score determines if the student passed or the student failed. That is the first thing we did. We changed the score values and ran that code. And when we did 70, we got a pass. When we changed to 44, let's get a 44. 44, we run that code and we got a fail. Key things, the if and the else must be on the same line. The print statement has to be on the same line. If it does not, then if you shift the print inward, then this block, the if side of the block, will not see this print. So this print will not print the remark of the if. However, it's going to print the remark of the fail because it is part of it. So for you to get it to print all of them, you bring it to the same line with this. You run that and we got a fail. If we change this value to 45, we run that, we get a pass because we said greater than or equal to. If we do anything greater than 45, we'll see that we are going to get a pass. That is how it goes. We did that, we demonstrated that if and else. Then the next thing we did, we used the if else, and next take one if else. We take the if else and put it inside another if else again. That's what we did. Now we did that. We initialized, that is initial, meaning that we give a value to the grade and we gave it an empty space, just empty, nothing. Grade is that. So at the beginning, the grade is blank. And so we gave a score and we say if the score is greater than or equal to 70 and that score is less than 110, we did that because beyond 100, which is 101 and above, is an invalid score for an exam. So we did that and we say if the score, meaning that if the score lies between 70 and 100, that person got a A. Else, if we have brought another condition in, if the score is greater than or equal to 60 and the score is less than 70, grade is B. Else, if you see how we nested each if else inside to accommodate the number of conditions we have. So we brought the B condition and then we said if score is greater than or equal to 50 and score is less than 60, grade is C. Else, if the score is greater than or equal to 45 and the score is less than 50, the grade is D. Else, if the score is greater than or equal to 0 and the score is less than 45, then grade is F. We know that our grade will be between 0 and 100. So if it is anything above that, it's now an invalid score. So we consider that condition and we printed grade. And then we tested that and we saw how we got the various scores. We tested this. In this code now, we got grade is F. Grade is F. When we change this to some other value, let's assume we got 60. We got a grade of B. We tested that block of code. After we tested that block of code, we now define a function. Now, when we define a function, we now want to calculate this grade. We have tested this block. So we remove this block, copy this block, and put into the function. When we put that into the function, we see exactly that code there. We brought it in here and we arranged it. If you get the arrangement wrong, then you get it wrong something. So we arranged it and we ran the code, and we had no error. So now we assign how we can call that function. So we call the function by writing the function name and passing the number of variables that are defined in the function. In this case, we have just one variable. So we pass one variable. So whatever value we pass there, the grade is calculated and we assigned it to a variable. And then we printed that variable. So we tested it. We used 10 here. We run it. We get F. If we change this value to whatever, let's say 70, we run it, we get an A. Whichever value we do, so we can call this, we can use the function we have defined to calculate grade efficiently. Now, the next thing we did was that we get a list of values. And then now we want to loop through the values. We have a data set. Let's say that's our data set, and then we want to loop through the value. We cannot be typing one after the other. So we now use a for loop, a for statement that repeats itself. So we now say for boy, we can give any name we like here. It doesn't matter. So we say for boy, let's say that each item here, we'll call a boy. For boy in this data set, when you read it, ensure it's an integer. This is what we do. We are casting it, changing it, make sure it's an integer, and store it in the word item. And then we call the grade function that we have, grade calculating function that we have there. And then we pass this item into it. And whatever it comes, it returns it to GRD. And then here we printed the item because we want to see to confirm. And then we printed the grade. And now, when you run this code, we see what happened. And we see 45D, 78A, 90A, so on till we got to the end. So that is what we have done today. We have done a lot today, and so we will continue in the next video. Thank you very much.